Okay, I
I'm here.
all right. Okay, now there are like various ways to represent a vector. A quantity, you could like bold that particular letter. Okay, say a vector in this way, or you could like this is the most common way to represent a vector, like giving a arrowhead. Okay, arrowhead on top of the letter, and we sometimes also give a bar. Okay. Now notice doing like bold in that letter is sometimes difficult while we write. Okay. And if you do this, it might create some confusion between average and vectors, right? Because average is also represented in this way. Okay. So this one is the best way. All right. And whenever you are telling that, okay, this is the magnitude or absolute value of a vector, what do? You put a modulus sign. What is this sign called? A modulus sign. Okay. Okay, let me give you an example. Say this is say 5 Newton, okay, and this is a force vector, okay, it's a force vector. So you could say like force vector like this way, and the magnitude or the value of force vector will be represented like this way equals to 5 Newton, okay. This is just a value, not a vector, okay. It's 5. 5 is the magnitude or the value only, okay. I'm going a bit fast because you have the idea of these things, okay? Let me know if you find any confusion anywhere. Okay, clear? Can you hear me?
Yes.
Okay, all right, good. So, vector quantity is expressed by putting a line above a letter and its magnitude. Okay, so you know all this, right? I'm not going on that. Vector quantity is represented by putting a line underneath sometimes as well. The letter and its magnitude is expressed by. Okay, so you could like do something like this as well. I forgot to mention this. And to express its magnitude, it will be like modulus sign as well. A vector quantity is represented by a bold letter. For example, vector form of A is bold A and its magnitude is A. All right. So on, so on. We have seen all the possible representations, but I would suggest that you represent it in this way. This is the best way. Okay. All right. Any questions?
Yes.
Yes, go ahead.
Oh wait, no, sorry, no questions.
Okay. All right. Now, we might need to examine vector in three-dimensional space. Okay. So now, to like represent three-dimensional spaces in paper is really difficult. So say x and y axis is pretty easy to represent, but the z axis, okay, I don't know why they have shown axis here. So usually it's something like this. Okay, let me show it.
Hmm.
So in this direction it is x, in this direction it is y, okay, in this direction it is z. Now z means like, say for instance, do you have a corner of a wall? Can you see a corner of a wall in your room?
Yes, hopefully.
Okay, right. So in the right direction, you will see x-axis in the like say, what can I say? Not I mean say upward or downward direction. Not upward or downward. I mean say this is the point of the like wall, okay, corner point. So some wall has gone in this direction and some wall has gone in this direction, right? Is that correct?
Yes.
So this will be termed as y-axis, or like I mean consider it, or it is x-axis. And the height of the wall, in which direction the height has gone, it will be termed as z-axis. Okay, so we cannot like make a height, right? Okay, so that is why we show it like it seems like it's a 45-degree angle, but actually these are all 90-degree angles. Okay, this is 90 degree, this is 90 degree, and this is also 90 degree. Okay. Say for instance, in a particular point, x-axis has gone here, y-axis has gone here, and you put your pencil directly upwards in this direction. That will be our z-axis. Okay, clear?
Yes.
Okay, good. Hmm. All right. Now, vector representation. Different vector quantities are mathematically expressed in vector form. Okay, so say for instance, force. For the external cause which changes or tends to change the state of rest or motion of a body is called force. Obviously, you know about force because we previously read about force, right? What was force? Force was when we say apply apply force in any sort of object, the direction or the motion of that object changes. Okay, so oppositely, we could say that the particular property which changes the direction or the speed of an object, that is termed as force. Okay, that is termed as force. So uh, obviously we know that the force is mass times acceleration, but here you can see that acceleration is a vector quantity. Okay, because acceleration involves direction, like to the right or to the left or to the forward or to the backward. Remember, we also seen something called deceleration, right? Deceleration means
Yes.
like trying to exert the acceleration in the opposite direction, in the direction my vehicle goes. Okay, or is going. And obviously you understand force obviously has a direction. All right. Now, rotational force or centripetal force. Okay, all right. Now you will see various videos where a particular society is saying that there is no centripetal force, there is only centrifugal force. Okay, and
Huh?
a particular society will say that there is no centrifugal force, there is only centripetal force. Okay, however, we will not go on to that. Okay, so let's just say a particular object is moving in a circular path. Okay, let me draw it for you. Say this is an object moving in a circular path. Okay, moving in a circular path. In whichever point it is, it will feel a particular force towards the center of that, path. Okay, center of that path. Okay, say for instance, this is your finger. Okay, this is your finger. Okay, you have tied something here and you are rotating a thread, okay, in this direction. You will always feel, or that particular object will always feel that it is, getting a force towards your finger. Okay, so this thing or this phenomenon is termed as centripetal force. Okay, all right. Now, what is the difference between centripetal and centrifugal force? I am not going into that because there is a very debatable issue. Okay, just for our understanding, let us consider this is centripetal force. Okay. Anyway, so let's see the definition. Do you understand what is happening here? Like something is moving in a circular path and it is sort of, feeling some sort of force in the center, towards the center. Okay, that is the as simple as it gets. Okay. Now, when an object revolves in a circular path, the force that acts on the body in the direction of the center of the circle so that it keeps the object in circular motion is called rotational force or centripetal force. I hope it is like really clear, right? There are no difficult wordings here. All right.
Yes.
Are you understanding? You seem to be very quiet today.
I drove for 2 hours.
You drove for 2 hours. Okay. Was it
Yes.
in the your area, like or like highway? Where?
Highway.
Highway. Highway, highway driving is enjoyable, you know. I
It's scary.
particularly,
I mean, for your first time.
yeah, I particularly do not enjoy driving in the like city because I I live in Dhaka. So what happens is there is extreme congestion in this city. Like you just have to sit for say minutes after minutes in the signal or because of the traffic congestion. So that is boring. There is not any enjoyable drive. But in highway, the driving is enjoyable. But as you said, yes, it's a little, you could say you need 200% concentration because any sort of mistake in highway means it's not a say limited injury. Okay. Okay, your car will be gone and you might also be gone. That is the problem. But in case of like city driving, okay, what will happen? Say you might get a scratch in the car, or something like that. So yes, in that way, you could say that highway driving is like, what can I say? It's a frightening a little bit, but you will get used to it, okay, and you will enjoy it sometime. Anyway, so where was I? So this is centripetal force. All right. Now, we will discuss them in detail in fourth chapter. Okay. I think it's not necessary in the vector chapter now. So because if we discuss them without discussing force, it might get a little difficult for you. Okay. Like what is omega? You don't even know what is omega. Omega is the
Amps.
an-
Resistance.
angular velocity. Okay. This is angular
Oh,
velocity,
what?
or
Oh, okay.
you could say circular velocity. Okay. All right. So you just only have the idea about linear velocity. Now, again, angular velocity. Why is angular this velocity equals to angular velocity times the radius? Okay. You don't have any idea of these. Okay. So you will get the idea of these in the dynamics chapter. So let us focus just on, vector for the time being. Okay. All right. Now, what they're saying, surface. Okay. So the direction represented by the normal drawn on a plane or surface is the vector of that surface. All right. Say, in this case, the vector or the direction of the surface is from left to right. Okay. It is from left to right. All right. Okay. So direction, normal, normal. Right? Normal means like you could say perpendicular drawn from the surface. Okay. All right. Again, in this case, you could see the normal is in this direction. Okay. So in this case, the plane is the surface. The normal drawn on a surface is called the surface vector of that surface. Okay. I mean, okay, one second. In the following figure, surface vector has been shown by dotted line. Okay. Let me like simplify the things. Okay. Say for instance, this is a like coil. I mean, not the coil like which will exert magnetic fields. Again, you don't understand about magnetic fields, but say it is exerting some magnetic field in this direction. Okay, in this direction. Okay, so this is the direction of the magnetic field, which is from left to the right. Now it is being exerted by a particular surface. Okay. Now obviously you would say, okay, surface cannot be a vector, right? Surface doesn't have any direction. But however, if we draw a normal from that particular surface, the direction it shows will be a surface of that vector. Sorry, I mean surface vector. This is a surface vector. Now again, we have somewhat rotated this surface. Okay. Then the normal of that vector already changes. Okay. Again, in this direction, it is also changes. Okay. So now
Mhm.
why is it important? Why is it important is because you will see various components in the future of vector chapter. Say for instance, we will see, so work. Okay. So work equals to
FD.
FD or FS, yes, FD. Right.
Oh, yeah.
Now F vector dot product distance vector or displacement vector. Now here you have to understand that if F vector goes in this direction and say this is the like this is particular plane where distance is happening. Okay, this is the distance. Now if you don't understand that there is a particular angular involvement between force and displacement, you will not be able to calculate the exact value of work. Okay, because what is the dot product? Dot product of f vector dot d vector equals to fd cosine theta. Write this down. Fd cosine theta. Okay. So say for instance, see these three cases. Okay. In one case, the angle between the magnetic field and the surface vector is 90 degree. The angle between this here is theta. Say for example 45 degree. And angle in this case is 0 degrees, or the direction is same. So in all the cases, the effect of the magnetic field won't be same on the surface. It will change. Understand my point? And same is the case, say if you have the angle of force and displacement to be 90-degree, according to the language of physics, there is no particular work happening in that particular system. Okay, because cosine 90 equals to 0.
Mm.
But if there is like 0 degree, say for instance, I'm applying a force of 5 Newton, okay, in this direction, and also the the plane on which, or the displacement direction on which it is occurring is also the right direction. So that means the angle between these two is 0 degrees, right?
Mm.
Understand my point? Anything parallel to each other will be 0 degrees, right? We know that. But the angle between two parallel lines is what? 0 degrees. Remember that?
Yes.
Okay. Parallel and in the same direction, obviously. And say, for instance, 5 Newton in this direction and displacement is going on this direction. That will be a negative one because you will get cosine, say for the minus 180. Cosine minus 180 is minus 1. Okay. All right. So these are the particular things important. That is why they are showing the surface vector. Why is it is important? Okay. Because you have to be able to understand how the angle of two particular vectors work. Okay. So yeah, that's pretty much it. Okay. Tell me if you have any questions.
No.
Okay, good. Have you taken notes of these?
Yes.
Okay. Do you have any Arabic lesson today, by the way? I'm already 5 actually. I mean 9.
Yes, I do, and it's in a minute.
In how much time?
In a minute.
Can I continue about 10 minutes? Yes. Uh,
I can.
okay.
I can
That
say
can.
extends.
Okay, I think that will be better. Okay. So just compare two or more topics. Okay. Right. You're a busy man. Okay,
Yeah,
so if
I know.
if x is the, all right, let's just go on real quick. If x is the uniform scalar function in a field, then a surface may be considered passing through a point in that field. As I said, the angle would be 0 degrees, right? If x is the uniform continuous scalar function. See, okay, and then a surface may be considered passing through a point in that field. Okay, its surface vector is considered passing through that field. See, they have just considered one particular point in which direction, and they have drawn a normal, and in that direction it is passing. Okay, they are saying in like that. Okay, all right. In this case, it is also like that. Okay, so in all the cases of surface vector, they're considering one particular point. Okay, now
Yes.
uniform potential surface is a base. Okay, that's pretty much it. I mean, don't just read these things, just remember this like images, that will be easier for you. Okay, you don't have to like remember these bookish definitions, right? Hmm. Now if the position function at a point is v and coordinate of that point in rectangular coordinate system is x y v, then delta v is okay, rate of change. Now this is particularly easier. Why is this rate of change? Rate of change, remember, whenever you are said like rate of change or slope or something, you will remember that you have to differentiate it in terms of x. Oh, okay, you don't know differentiation, I guess, right?
I do not. Sorry.
For the time being, let me tell you. So, for instance, say velocity is increasing by time. Okay, so this is a velocity time graph. Okay, in this direction, this is velocity. This direction is time. What did I draw it? Velocity, time. Time is independent, right? Time is, sorry, velocity in this direction and time in this direction, because time is independent variable, right? Okay. Now notice if I want to see the change in velocity with respect to time, what I do is say for instance, draw something like this, okay, and then say take this particular angle, okay, and then do tan theta. Tan theta will be equal to y upon x, right? Is it correct?
Yes.
Now, when the rate of change is like very minimal, like the say the time is like almost tends to zero, we call it dy by dx. Okay, like with d we represent like a very small change, very small amount of time. Okay, all right. So we will discuss them in detail in like differentiation chapter, and also in vector chapter. I will show some of the parts which involve differentiation. Okay. And for the timing, just remember this much. Okay. Okay. And what is the rate of change in velocity called? Tell me.
The pardon? Change of
What is the like? How can you term it? Like rate of change in velocity. What do you call it? I have
uh
taught you.
velocity.
Yes. It is
Meters per
acceleration.
second
Okay.
squared. Meters per second
Acceleration.
squared. Oh, accelerations, yeah.
Yes. Meters per second square. Yes. You can remember it in that way if you don't even remember the definition. Okay. But it is called acceleration. Okay. All right. Okay. Okay. Just these three definitions. If you divide any vector with its value, with its particular value, it will be termed as unit vector. Okay. Say I have a vector. Okay. A vector, and I divide with the value of f. Okay. It will be a unit vector. Obviously, you understand that unit means one, right? Unit vector. So if a vector is like has a value of 5 vector, say for instance, and you divide with 5, it will result in say 1. Okay. I mean, I'm just saying it for explanation. Okay. You don't represent it like 1. Okay. There is a particular way to represent it. So that is why it is termed as unit vector. Say in case they have shown a vector upon the value of a vector. It is an unit vector and you show it like a hat. A hat. Okay, what did I say? A hat. Okay, a hat. Understand?
Yes.
Okay. And obviously, you can understand that any no null vector cannot have a unit vector. Okay, null vector or zero vector cannot have a unit vector. Okay, all right. Now, next up, null or zero vector. The vector whose magnitude is zero is called a null or zero vector. They don't have any particular direction. You could consider them to be a point. Okay, all right. So
Yes.
what could be an example of null vector? Say a tug of war is happening in this direction. They are putting a 5 Newton force and they are putting a 5 Newton force. So they are opposing each other and this point could be termed as a null vector or zero vector as it is not moving in any direction. Okay. Okay. So they have said by adding a vector with its opposite vector or by subtracting two equal vectors, a null vector is obtained. Okay. Understand? I think these
Yes.
are very clear things. Okay, I think this is very clear. Okay, I think position vector. I am not going into that because it will take a little time. So we can start from the next day. So when are you free tomorrow?
Tomorrow we can
Mhm.
try. I'm pretty much free all day.
Okay, so when do you get up in the morning?
I can get up whenever.
No, you don't have to get up whenever. I
Like
mean,
today I woke up at 5 a.m. because it was
mhm.
flooding for a bit.
Flooding. Oh my gosh. Okay.
Yeah,
I hope you guys are
the
okay.
weather in Brisbane is very erratic. At one point
Yes,
it's like
yes.
we're in the middle of a heat wave, another is flooding.
Mhm.
Yeah.
Okay.
So anyways, but
I'm
yeah, when's your
Okay,
earliest
we will
or
have
when
the time to discuss them in the next day because you already have a like a lesson to
oh yeah,
get on. All
true.
right. So So is
I can wake
7
up
a.m.
at
too
8
early for you?
a.m.
Is 7
Saturday.
a.m.? No, I mean
7 a.m.
tomorrow.
Same 7 a.m. is not early for me.
Okay, so like 7 a.m. for your time, all right?
My time.
Is it-
7
Yes,
a.m. / 3 a.m.
right, right, right. Okay,
Goodbye to your sleep schedule.
all right. No, one day will be manageable. Okay, all right. Allah Hafiz for today.
Allah Hafiz. See you
All
tomorrow,
right.
inshallah.